Hello, I'm sure many of you have seen this phenomenon before. You place a ball in a stream of air coming from some kind of blower, and the ball just hangs there in the air and risks getting blown out, even if the stream of air is at an angle. Today I will explain why this happens. Here's our blower. We can hold a ping pong ball in part of the stream of air, and when we let go, the ball is drawn in and remains there, even if the blower is tilted. Let's look at the stream of air. Air, or any stream of fluid, has what is called a velocity profile, where the further inside the stream you go, the faster it travels. This is due to friction along the edges of the stream and the fact that the stream likes to stick together. Using something called Bernoulli's Principle, we can also look at the air pressure inside the stream. Since the air is moving such a small distance vertically in this example, the third part of each side is equal to each other. This means that the important parts of the equation look like this for this problem. We can rearrange the equation to put pressure and velocity on their own sides and simplify a little further. Now, you may notice that it's P1 minus P2 on one side and V2 minus V1 on the other. This means that if V2 is greater than V1, P1 must be greater than P2. So, if you have a fast-moving stream, the pressure inside the stream will be lower than the pressure outside the stream. So, as we are placing the ball on the edge of the stream, the velocity profile looks like this, and the pressures end up looking like this. The lower pressures on one side of the ball, due to the faster moving stream on that side, cause a net force pulling the ball into the stream. And this force exists unless the ball is exactly in the center of the stream, and the force always points towards the middle of the stream. This is why the ball is kept in the middle. But why does it float? This is also based on Bernoulli's Principle, but it also involves something called the Coanda Effect. This says that the air moving past the ball will want to stay close to the ball. And as it whacks into the ball at the bottom, it creates an area of high pressure. And as it moves around the top of the ball, it creates an area of low pressure in both cases because it just wants to keep moving up. This causes that same force, which balances with gravity, to keep the ball floating in the air. And it works as long as the force of gravity isn't pulling the ball too much sideways. This is why it also works at an angle. Thank you for watching, and the references I used for this video are given right here.